Like with any new subject, you have to learn the vocabulary so you know what we're talking about. Geometry is full of new ideas, concepts, and terms. Let's start with the basics. In geometry, we have what we call undefined terms. These are so basic and foundational that we automatically agree on what they are, but don't have specific definitions for. But we can explain some information about them. So the undefined terms that we'll talk about today are point, line, and plane. These are all undefined. But what we do know about them is that a point has no dimension. Point has no dimension. And it's represented by a dot. So if you turn the page, we can look at the drawing for a point. So a point is just represented by a dot. And we'll call this point A. Clean that up a little bit. It's going to be point A. And the notation we would use if we were writing that out would be point A. That's how we would say that. And so that has no dimension because it's just that single point. Let's go back to a line. A line has one dimension. Has one dimension. And it's represented by a line with two arrowheads. So the drawing would look like this. A line with two arrowheads at the end, and we've got points on that line, let's say points A and B. And so with this line that has points A and B, we would call this line AB. And we could write that as line AB. So we put AB and then we put a line with arrowheads on the top, and we could also reverse it. And call it line BA. Either of these would work. And notice that a line extends without end. That's what those arrowheads mean on the ends, is that it's just going to go on forever and ever in both of those directions. Okay, let's talk about a plane. A plane has two dimension. And it's represented by a shape that looks like a floor or a wall. So if we jump down to the drawing, it's represented by a shape that looks like this. And it also extends without end. So though we draw it with these edges here on the sides, it actually extends forever and ever in that two dimensions. And it has, a plane is made up of 3 points that are not all on the same line. So we would look here like ABC. And we can also name a plane by a capital letter. So notice how that M is in the corner there. That's not a point because there's not a dot next to it. A, B, and C are points because there are dots next to them. But that M is not a point. That's just the name of the plane. So if I were to name this plane and give it notation, I could call it plane ABC, or I could call it plane M. That would be two ways to name it. Either give 3 points that are on that plane, name it that way, or the capital letter that signifies this plane. In this case, it was M, because that M was in the corner. And you'll be able to tell again what's the name of the plane and what are points, because you'll see dots next to the points and you won't see a dot next to the name of that plane. It's important to understand the relationship between points, lines, and planes. A point is that single dot with no dimension, the most basic of geometric figures. A line extends and exists through any 2 points. A plane exists through any 3 points that are not all on the same line. Now that we have these undefined terms, we can start to actually define other geometric figures. All right, let's talk about these next 3 terms: segment, ray, and opposite rays. A segment, which can also be called a line segment, because it's a segment of a line or a portion of a line. It consists of 2 endpoints and all the points on the line in between those 2 points. Okay. Again, I understand that I went into the other box there. Obviously, you want to try to write as small as you can. I'll just be able to easily erase this once we come back to talk about array. So that's a segment. It's 2 endpoints and all the points on the line in between those 2 points. It looks something like this. Here's one endpoint, the line, another endpoint. Endpoint at A, endpoint at B. And then all the points in between A and B on that line are part of the segment as well. And we could call this segment AB, and notice I just put the line above it, or I could do segment BA. Either way would work. All right, let's talk about array. I'm going to delete this a little bit. A ray consists of a single endpoint and all the points on the line that lie on the same side of that endpoint. So let me write that out. A ray consists of a single endpoint and all the points on the line that lie on the same side of that endpoint. So array has a single endpoint and then extends out in one particular direction and contains all the points that lie on the line on the same side of that endpoint. So let's look at a drawing of that, because I think that'll be helpful. Okay, array could look like this. Has a single endpoint and then extends out in one direction. So it has endpoint at A and then all the points in that direction on the same side of A. So all the points on the side of B would also be on the array. But it could also look like this, have an endpoint at B and extend out this way. So that is also a ray. But it's important to remember that those are actually two different rays. And why is that? Because they have different endpoints. This one has an endpoint on A, and this one has an endpoint on B. So that makes them two different rays. And so we would write them differently. We would say that one of the rays is AB, because A is the endpoint, and one of the rays is BA, because that's the endpoint. So notice that up here with segment, these were the same segment. But here, these are different rays. Okay? With segments, you can change the order of letters and it's still the same. With rays, because they just have one endpoint, you have to pay attention to the fact that those are different rays if they have different endpoints. And notice again, the symbol that I'm using is just a ray above the letters. That signifies that it is a ray. All right? Let's talk about the last one, opposite rays. Opposite rays are two rays that have a common endpoint and extend in opposite directions. Two rays with a common endpoint that extend in opposite directions. That's what it means to have opposite rays. So let's look at the drawing of that as an example. Okay. So opposite rays. It could look something like this. Let's say we have this line AB. We have this line AB. And on that line is point C. Somewhere on that line is point C. Well, this line would actually, from C, have a common endpoint at C. So we would say that we have two rays here. Ray CA and ray CB. Because one ray is going CA this way, and the other ray is going CB this way. And so those are two different rays with a common endpoint of C. Okay, and that can happen on a line. And obviously they're forming a line with that common endpoint, but we can also say that those are opposite rays because they have that common endpoint of C extending out into different directions. These important terms will stay with us throughout the rest of our geometric studies. So now jump over to lesson 1.1 examples to see how this all goes together.